live webinar. We are starting today to talk about a very specific topic, electrifying mine. I propose to wait a few minutes more that people can join. Meantime, I will kick off with the introduction as we are used to do. So for a short introduction about AVERE itself, for those who are not familiar with the organization, so AVERE is going as an association for electrifying transport modalities already since '78. We have an academic origin, but we indeed are moving forwards towards a fully organization representing members, national sections in more than 20 member states, which represent then 2,300 indirect members and over 100,000 EV users. So it makes us quite unique to represent as well the industry, as well the users in one organization. We have broad activities and also broad memberships, from going CPOs to charging point operators, car manufacturers, in the battery sector, but also in the supply chain of components. About the webinar is recorded. The participants will receive the link to the recording after the event. We will make the presentations available upon the speaker's agreement. During the webinar, you can post your questions in the Q&A box. Don't use the chat function, please. Questions can be upvoted if ever necessary, and we also limit the questions over the Q&A to 5 minutes or 5 questions in order to respect the timing of the webinar. Statements will not be handled, so we really focus on questions that people have raised. Views expressed during this webinar do not necessarily represent the views or policies of AVERE or its individual members. So the speakers are speaking on behalf of their own organization. As already indicated, it's about the next steps of electrifying, and we have been covering the easy things in the first place, and from bikes to really megatons. Our topic goes indeed to the megatons and on the specifications that brings among it. So we need specific technologies, specific powertrains and batteries. And this brings me automatically to our speakers of today. We have Robert Trebeski. He's the Director International Business of Ostmine. And we have Scott Davies, leading the Innovation Zero Emissions Material Movement at Minerals Australia. So, as well understood, it's evening on your side, but we manage, of course. Thank you, Robert. Welcome. Thank you, Scott, also to be here today. The floor is yours. I will stop sharing the screen and give it over towards you.
Thank you, Philippe. Good morning. As we simply say in Australia, good day, wherever you are in the world. I would like to thank specifically AVERE for hosting and organizing this webinar for Ostmine and the founding patients of this challenge, BHP, Rio Tinto and Vale. Especially Philippe has been instrumental in putting this all together in a very short period of time, and also giving the holidays. It's been a great effort, so thank you very much, Philippe. And also would like to thank Aspen Hook, whom are connected to initiate this relationship between Ostmine and AVERE. Very briefly, Ostmine, similar to AVERE, is an industry organization. We are a membership body for the supplier industry for the mining companies. So we represent the companies that supply goods and services to the mining industry globally. We are an Australian organization. I am based in Sydney. As you can see, there's fairly coal in our part of the world, but we are basically working on a number of projects, and one of the projects we worked on has been the Supply Innovation Program with BHP. And I'll briefly about BHP. You might not be necessarily very familiar with the mining industry, so some of the names might not be very common, but basically we started working on a project on identifying solutions among suppliers for certain challenges that BHP have on their sides across Australia. It could be technical, could be operational, or both. And then we embarked on we were commissioned to work, so this next slide, to work with BHP and Rio Tinto and Vale on the Charge On Innovation Challenge. And just to give you a context, BHP, Rio Tinto and Vale are the three biggest mining companies in the world. They are really the biggest companies in terms of production, size, operation, etc. And interesting enough, they are also direct competitors. So something fairly innovative in this industry, to see three biggest mining companies in the world and competitors to team up, to collaborate on what we call basically the challenge to increasing electrifications of certain operating machinery, but ultimately to decarbonize mines and reduce emissions. We are obviously working with other stakeholders, and we call, as you can see, patrons are basically mining companies that, as you can see, you will see shortly. Other mining companies came on board. So what is this all about? This is basically a challenge, an opportunity for innovators, solution providers to participate in this international, global challenge across the industries. So this is basically a challenge, an opportunity for your companies, supplier companies coming from very different background, from very different industry, very different jurisdictions, that never worked in mining, that never worked in any of the jurisdictions where most of these mining companies operate, to expand your horizon in terms of working with very different industry sector in new markets. So we're calling basically technology suppliers to come and support this challenge in participating by providing their expertise and solutions. This challenge is specifically about open pit operations, and it's specific about, and as Scotty will present you, is specifically about one type of technology where we're sourcing solutions. On this slide, you can see that, again, BHP, Rio Tinto and Vale are the founding patrons. This challenge has been joined by 11 other mining companies from almost all continents, covering almost all commodities, whether it's iron ore, coal, gold, copper, from almost all continents are here part of the challenge as patrons. So these companies will work over the next roughly 6 months together to basically identifying the best solution for the industry out of the possibly 100, 120 solution submissions that we have received or are receiving from the supplier industry. So just to give you an idea of what impact the operations all of these mining companies have in terms of emissions, diesel or fuel consumption. The next slide gives you a really good understanding of this. And now I would like to hand over to Scott Davis to provide you with his view on this challenge. Thank you, Scott.
Thanks, Robert. And thanks everyone for the opportunity to talk to you about this challenge, and for Robert for the introduction there. So to give everyone an idea of scale, this graphic provides an indication of where all of the patron mining companies have operations. So you can see there is quite a spread around the globe as to where those operations are located. We also use a significant volume of energy. So across the patron group, together we use over 4 billion litres of diesel per annum just in our trucks. So if we are to convert that into electricity, we'll need to create in the order of 80,000 gigawatt hours and transfer that into a battery electric truck each year. So you can see that the scale is quite amazingly large. And to give you an idea, if Robert, we can go to the next slide, of the size of these trucks. This is a 220-ton dump truck. We are focused on this size at the smaller end of the range, but we do have trucks which go up to a 360 metric ton payload. So we're talking about very large pieces of equipment and equipment that uses a lot of energy. If we can go to the next slide, Robert. So in terms of particularly the founding patrons of BHP, Rio Tinto and Vale, we have set decarbonisation targets individually, as has many of the other companies who have joined the chat. So we are looking at a range of different pathways to decarbonise, and electrification is the main priority and something that we all had in common, and therefore we've chosen to focus our first steps around how do we electrify our mining operations. Some of the other things that we are looking at include hydrogen, but we see that there is potentially a greater opportunity by using electricity directly and using the efficiency benefit rather than converting that electricity into green hydrogen. So at the moment, the battery technology is a constraint in terms of how much energy we can actually carry on board the truck. And just one moment, please. Apologies for that, working from home. So the battery is a constraint in terms of the amount of energy it can contain. So if we were to just use the existing charging technology, we would have to buy considerably more trucks in order to maintain the same production. So what we are looking to do is to say, instead of taking trucks out of service for charging or out of their operation, can we actually provide that energy to the truck while it's actually hauling to and from the digging location to the dumping location? So that might be while it's traveling, or it might be while it's actually stationary being loaded or dumping. So really what this provides by doing in-cycle charging is an opportunity to have a smaller battery and therefore not to compromise on our payloads, have fewer truck numbers and maximize the productivity of mining operations. Next slide, please, Robert. So to visualize what the challenge is all about, if you imagine on the top left of the screen, we have in typical mines a high voltage distribution point for electricity. We want to connect from that point and take electrons into the battery electric truck. And therefore we are very interested within scope, the green highlight, which is the piece of technology, let's call it the charging technology, that delivers electrons to the truck, inclusive of the battery because of the strong interplay between the battery and the charging technology. It also therefore includes whatever connection mechanism is appropriate to join the charger with the battery. If the truck is actually traveling, those electrons can charge the battery as well as provide propulsion to the truck directly to the drivetrain. So in terms of that type of technology, that could be a pantograph catenary style system that you see in electrified railways. It could be a plug type operation. it could be an inductive connection, it could be a battery swap. So we're really quite open as to what the charging interface looks like. The challenge is for each haul cycle, and in mining, the haul cycle is made up of the truck will queue. Sometimes it doesn't queue at all. Sometimes it might queue for up to 3 minutes before it goes underneath the excavator where it is loaded, typically for 3 minutes. And then it will travel to a dumping location, either a primary crusher where that location doesn't change for many years, or it might go to a waste dump where that location is continually changing. So it then travels, it gets to the dumping location, dumps, and then returns to queue and be loaded. So that whole process, the time will vary. It could be as small as 15 minutes. It could be over 30 minutes for one haul cycle. We want to be able to deliver 400 kilowatt hours into that haul cycle, either in one point or in multiple points in that haul cycle. And that will depend on what the solution looks like. There is a constraint that we have put on the truck, and that is to say that by pulling out the diesel engine and the fuel tank and so on, we have space and weight where we can put 17 ton of equipment onto the truck in a space of 23 cubic meters. So the challenge doesn't specify the exact geometry of that constraint, and that will happen after the challenge when we start developing these solutions and looking at getting them ready for development and demonstration and trialing in pit. So to summarize, we're looking at how do we get electrons from a high voltage supply point on the mine site, delivered into a truck where the truck may be stationary or moving. And we are particularly interested in the charger, the interface where the charger connects to the truck, and the battery, and describing what that solution looks like. We will be accepting solutions that are non-compliant. This is an aspirational objective that we have. So therefore, any vendor who doesn't quite meet the 400 kilowatt hours can still submit, or you can submit if you have part of a solution. So for example, you might be a battery company that has a high C battery that might be quite useful for this application. And Robert, through Osmine, will provide assistance, and we can talk more about this in the Q&A, but we will provide assistance to you to find other organizations if you're looking for a partner to provide a full, complete solution. Okay, let's move on to the next slide. Some key things, therefore, about that challenge is we want the solution to be scalable. So initially, we're targeting that 220 ton payload truck. We want to take that up to 360 ton trucks eventually. We want solutions that are interoperable, meaning we want to be able to have trucks from different equipment manufacturers using the same charging interface, so that if we invest as a mining company into a whole lot of charging equipment, we want to be able to swap out our truck fleets to different manufacturers and still use the same charging equipment. Some mine sites also use trucks from different manufacturers on them as well, where that becomes important. We obviously want to deliver that electricity safely to the truck without adding time to the haul cycle if possible. One of the questions that we often get in terms of the solution is that we are open to different interpretations of how that energy is delivered to the truck. So if in doubt, we encourage you to put forward a submission or reach out to us separately to this webinar to find out if you think a solution that you have in mind might be valid. But we're really looking laterally to open people's minds in terms of how we think about solving this problem. We can also think about mobile charging solutions as well. So there may be particular solutions that are extremely mobile and provide a lot of flexibility to operations that don't deliver a whole 400 kilowatt hours to the truck, but that may also add value as part of a broader solution. So we're looking at it from a systems point of view as well. Next slide, please, Robert. So in terms of the timeline, we've been promoting the challenge since May. The challenge is split into two core phases. So we've got an expression of interest phase, which we're currently in, and that closes on the 31st of July. And that is intentionally high level and requires minimal effort on behalf of the vendor in order to put forward a proposal into the process. The idea is that those proposals will be reviewed by the patrons collective, well, individually evaluated, but we'll come to a collective shortlist as to who we want to ask to submit a full submission, which that requires more effort and more detail in terms of the work on the vendor side. So the idea is, by having the EOI, we wanted to not have everyone go through and complete a detailed submission, but just really do enough work to work out who needs to be on that short list, where we then invite the shortlisted vendors to do a video pitch, and the patrons will provide feedback to each vendor individually on things that we like about the pitch or questions that we may have that the vendor can then incorporate into the final submission, which is due on the 1st of November. When we get to the final submission, the patrons will come together in a series of workshops to understand what are the areas that we have in common in terms of the pathway forward, such that we can identify a small number of concepts that we can support and assist them in the commercialization process. So that will involve, and if we can go to the next slide, Robert. So that will involve going from step one, which is the charge on challenge finishing in December 21, as per the previous slide. And then we will come together in a broader consortium setup series of workshops where we'll invite the selected vendors from the challenge together with truck OEMs and also prospective investors to look at how we can then support those particular concepts be developed into a working solution that can be demonstrated on a mine site and ultimately scaled up to be a commercially available product. The one thing to point out here in step two is the role of the prospective investors. So we have been talking to a number of large multinational investment companies who see this as a great opportunity to have a global tech scan, in essence, conducted by the end user with a selection process to then identify particular technologies that we want to progress as an industry. And that's a really good input into their investment decisions because they have dollars that they're looking to find homes for in terms of different styles of investment. So that's something that we want to facilitate and really support the vendors. And some vendors will have different needs, but we are looking at providing as much support as we can to help commercialize these technologies. We then move following that consortium setup. The intention is to then actually put in place a contractual framework that allow us to work together to develop these concepts and get them ready for demonstration on a mine site from as early as 2023. So certainly happy to hear solutions that are available earlier, but we're really looking in that 2023 to 2025 period as where we would like to get something that can be demonstrated at scale. So that's where all of this is heading. If we go to the next slide, the benefits of participating in the challenge are multiple. So first of all, it's an opportunity to receive financial support. So that could be in terms of participating in a consortium whereby there is the equivalent of grant money provided, which might be in exchange for licensing conditions or something like that. It's also, there might be prospective investors looking at equity. So depending on the maturity of each company, that might be attractive to some companies and not to others. And there might be, opportunities for other things like debt financing and so on. Next, it's also an opportunity to showcase your technology to an industry that is growing in demand and looking to decarbonize through electrification. So it's a potential new market for you and an opportunity to get in front of a large segment of that market in one sitting. We will be looking at providing recognition to vendors, not just the ones who make it into a consortium at the end, but there may be particularly innovative ideas that we really like as an industry that may not fit with the consortium, but we want to recognize, and so we'll be looking at making those kind of recognitions. It's an opportunity to do site trials. So with the global footprint that we identified, there will be multiple opportunities, I expect, whereby you'll be able to trial your product in a mining environment. We also see that the challenge as having an opportunity to help define standards. So in terms of what a standard interface looks like for a large mining truck, we want to be able to turn that into a standard such that different vendors in the market can provide solutions that interface with that standard, and we can promote a competitive market. And it also allows you to develop key relationships, not just with mining companies, but also potentially through those truck equipment manufacturers and the prospective investors. And overall, we think it's a great opportunity for branding in terms of helping the mining industry reach our carbon neutrality goals, which means that the metals that we mine that go into, for example, batteries and electric vehicles, that we can actually make those metals green metals and therefore get that circular economy and get net zero in the products as well as our scope 1 and 2 emissions. I think that's the last slide, Robert. So that's all in terms of a formal presentation, and we love the opportunity to answer any questions that you may have. And thank you again for the opportunity to come and talk about this great project with you.
So thank you. We see indeed many challenges on this, and we can maybe address the questions that we have seen here today. First question that I see in the Q&A box is, what about decarbonization of light truck diesels you use?
Okay, so we do have many light vehicles, lots of small trucks, and if you look at the emissions that come from our haul trucks, they are just so overwhelmingly larger than the emissions from our small equipment and our light vehicles that we really wanted to focus our effort on where the problem was. So the rest of the world is already developing solutions for electric light vehicles, but no one's really got a solution for a zero carbon mining truck, which is where our emissions really come from.
Okay, thank you. Then I have another question from the audience. It would be nice to see what kind of electric commercial vehicles are needed by mining sector, power, electric range, payload, fast charging.
I guess that's a similar
Yeah,
question
it's quite
to the last
similar.
one.
Yeah. Not specific an answer on this, but it's quite similar with the answer you have given, I think. Yeah.
Yeah, look, I think as Robert said at the start of the presentation, we are very much focused on surface mining. There are a lot more solutions that are starting to come into mining in the underground environment, where we have smaller size machines as well as light vehicles that operate underground, and there are solutions already coming onto the market. So we see that more a case of adoption, whereas we're focused at the moment on the development need in order to decarbonize. So, we have limited bandwidth in terms of what we can focus on as an industry. So we really wanted to tackle the issue where we see the problem, which is diesel use in trucks is 60% of the emissions base for diesel.
Okay, last question. People are getting raised more questions, I see. So what do you see as the biggest challenge on the technology side? We indeed cover really big trucks. Do you see more constraints on the grid side, or do you see a development of battery capacity? Where do you see the...
Yes, good question. So I think there are many challenges. I think first of all, in terms of the grid, there are different places in the world that these challenges will manifest differently. So for example, in our operations in Chile, we are moving towards 100% renewable energy from the grid in our next contract, which is about to come into play. So from that point of view, they already have 100% green electrons, and therefore the challenge is all about how do you then get those green electrons to the truck. In other parts of the world, in mining operations, the grid is less green, they have less opportunities, and so therefore it will be a challenge to decarbonize the emissions from the grid supply of electricity. So that will potentially be an issue. But I think overwhelmingly, probably the biggest problem that is common across all of them is the battery technology in the truck. And then depending on how you interact with it, we're probably going to create some more problems by having potentially 5-10 megawatt fast chargers, causing then large transient currents and management of those spikes in load on relatively small electricity grids. So by relatively small, I'm thinking of around the 100 megawatt scale.
Okay, thank you. As a really connected to another question is also where put is every mine connected to a high power grid, and is the power station green? I think you covered.
I could add one thing to that, which is that in terms of the larger mining companies, they tend to either be connected to a national market or some kind of a grid like that, or they have quite a large grid themselves. So in terms of the challenge, we have companies who tend to be the large companies from the industry. So we're concentrating that effort, and those companies on a weighted average basis would have either direct access to markets and therefore power purchase agreements and those kind of instruments. Some of them have their own grids and therefore would have access to gas pipelines to run thermal generation using gas. And a lot of the more remote mines or the smaller mines run on diesel generation. And what we're seeing now increasingly is that small mines are putting in solar combined with diesel as a way of reducing the emissions intensity. And even more recently, we're starting to see solar, wind, diesel in those locations. So there will be challenges in decarbonising the power grid. Some of them have already got there. Some of them will probably take another decade to get significant reductions to where we need to be.
Yeah. Apparently, you touched also the question about that you're looking for an in-wheel motor. The question that gets there is, I think, because you need space for the battery. Is that correctly?
So typically, if you think of mining trucks, there are two varieties. There's a mechanical drive truck, which has big diesel engine, a gearbox, mechanical drive driving the wheels, or a diesel electric, which has a big diesel engine driving an alternator and has the wheel motors inside the wheel. So where the industry is going is that the battery electric truck will use the same wheel motors, and it'll just be replacing the diesel engine and the fuel tank with the battery and the DC-DC converters and so on, to then power the existing electric foundation, if you like, of those trucks. Now, there will obviously be opportunities to improve. It's not a simple swap out, but at a high level, it's analogous to that.
So indeed, you already have kind of electric trucks with the power drivetrain. So it's just to replace the energy source from a generator to a battery pack.
In the case of the diesel electric trucks, yes.
Yeah. Okay.
That is a little bit of a simplification, but I think it gets across the concept.
Yeah. Questions are continuously popping in. So, are you looking for a global supply of the vehicles to avoid CO2 from logistics of these vehicles?
So in terms of, I'm not sure if that's referring to the global supply chain for delivering those vehicles, or do we want some vendor who is capable of delivering these solutions to a global customer base? So I'll start with the latter and say that you don't have to have the capability to deliver to a global base, but that's something that we might look at in the consortium stage, where we help identify how do we scale up and commercialize these products and make them available to a global customer base. So I think definitely, we'll be looking at how do we support the vendor make that technology available to operations all over the world, and what is the supply chain requirement to support that. We are also, in terms of the global supply chain that supplies that, we are working with shipping companies who we use for shipping our ore all around the world. So in terms of those transport of goods, we are working with those partners to decarbonize their supply chains as well.
I think you partially answered another question, which is here from Natsal Tan. He says, yeah, I apologize, but I think many of us are unfamiliar with mining, but could you also share what other parts of this industry could do with more decarbonization? So you already...
Yeah, I can add to that though. I think, so if you look at, typically with mining, half of the emissions come from electricity, and the electricity is used to power things like primary crushers, screening operations, and processing plants. And so that they're a large user of electrical energy. Then we have diesel use is another, well, it's probably 40% electricity, 40% diesel in typical mines, although these are big ranges, obviously, depending on the actual mine. But the next is diesel, where within the diesel usage, the far and away the biggest user of the diesel is the trucks, followed by the diggers or the excavators. Then, depending on the commodity, heat is another source. So high temperature heat, which could be as high as 1300 degrees. So at the moment, that may be supplied from natural gas or fuel oil or something like that, or they're probably the more common ones. So we will also, as an industry, be looking at how do we decarbonize those high temperature requirements. And that's where there's a lot of popularity around hydrogen as maybe a good first step for utilization of hydrogen in the industry.
Which brings me indeed to the question, did you look into other solutions for decarbonizing as hydrogen? That's a question which also came up here.
So we have, I guess, as I said at the start, that the companies who are involved in the challenge see electrification as very important, and we need to understand, can we find a solution for electrification? Many companies are also progressing hydrogen as a hydrogen battery electric truck, or hydrogen in a combustion engine as an alternative pathway. And that with it brings with it a lot of complexity in terms of the whole hydrogen supply chain and the cost of that delivered hydrogen. So I think it depends on who you talk to as to what you think is the best solution. There are 2 mining companies who are building hydrogen fuel cell electric vehicle trucks because they believe hydrogen is the better energy medium as opposed to electricity. But I think overall, the weight of the industry is more focused on electrification first, and things that we find too difficult to electrify, then we'll look at things like hydrogen and synthetic diesels and these other fuels.
That's indeed a confirmation also from our aim. You look in what you can do electrified, and if that is absolutely not possible, then we look for the other solution. It brings me to, I want to conclude with one question. You said that you need really huge charging capacities. Did you ever consider also with battery swaps, that you can slowly charge one battery pack and then swap them available, or is the cost price
No. So in terms of how that energy is delivered to the truck, we don't care if it's delivered as a battery swap, as a plug, as a pantograph, as an inductive charge. So everything is on the table as to how you get those 400 kilowatt hours into the truck each cycle. So if it is a battery swap, it just needs to be like a Formula One pit stop, where you can do that very quickly. And we are seeing solutions being developed for large batteries. Just to give you an idea, I should have mentioned it earlier. The expected size of the battery in the truck would be, probably somewhere between 600 kilowatt hours and 1,000 kilowatt hours of storage. So depending on the solution, there are scenarios where it might be outside of that range, but that gives you some idea of the expected size of the battery necessary to propel the truck.
Perfectly. I see still questions showing up. I think we had, I would like to conclude from here, let's say it like that way. I still think that many people will come with more questions. You're reaching out to electrify your mining trucks. I suppose that we can address these questions directly to you, that you're still available.
So yeah, if there's any further questions, if people want to reach out directly to Robert, and Robert will be able to coordinate any responses to those questions. And probably the last thing, if I could say, Philippe, from myself before maybe Robert has a parting comment, is it was really important for us to reach out during the challenge to other sectors, non-mining sectors, and look at what ideas that these other sectors might be able to bring to us as the mining industry, but also it provides a potential new market for those adjacent sectors. So if there's any way that either through Charge On or more broadly beyond this particular challenge, that we can find ways to work together for mutual benefit, then we're certainly open to having those conversations and really encourage vendors to participate, and even just registering and getting involved and being within that ecosystem. You never know what might happen over the course of the challenge and the rest of the year as to what opportunities may present, even if you've only got a part of a solution or a good idea. We want to work with you to turn good ideas into potential products. So
yeah, just to maybe final words from me is that all of the process happens through the website chargeoninnovation.com. Vendors or interested parties can register. It's absolutely free, and it's and if you have any specific questions, please contact me directly at Osmine, Robert at osmine.com.au. Send any questions that you might have or any information you might require. But obviously, the whole process of submitting expressions of interest does occur on the chargeoninnovation.com website, and there is a vendor platform for where you need to register and basically submit your idea.
So indeed, this was the goal. Also see some remarks here in the chat. It was indeed to bring the dialogue on the table from the challenges in a really very specific industries. I'm happy that you also were looking to electrification on that side. We need to decarbonize a lot of industries. So please address your questions towards Robert. He was happy to handle them. And let's continue the dialogue on this. I'm happy that we kicked it off and that you on Charge on the Innovation Challenge put this on the table and reached out. So thank you very much, Robert. Thank you very much, Scott. You have shared very nice insights in this niche market. We hope to continue and to trigger the dialogue with AVERE, and would like to thank you from here on.
We would like to thank you, Philippe. And
thank you, Philippe.
Thank you very much.
I appreciate the opportunity.
Yeah, you're welcome. So this brings me to the end of our webinar. Thank you very much, everyone. We hope to see you soon after the holidays. Many among us are in holiday mode, July, August, typically in Europe. So we are also back at the end of the year with our AVERE e-mobility conference. Keep on having the dialogue, keep on looking for the opportunities. Thank you very much. Keep in touch. Have a nice day. Bye.